So, yes, welcome, and we will start. Let's talk about state machines in Pinball and how you can use them to implement game logic. And this is basically what we'll be talking about and what we will try at the end. So I got like a small state machine on the bottom on this slide here, and you will hopefully understand what this means later on. If you do not understand yet, that's not a problem. We will start in the very beginning, but leave out all the math and just show you the cool stuff about it. So, our agenda today is like, what are state machines? So that will be like a short detour to computer science theory. So like deterministic finite automatons and non-deterministic finite automatons, and what you need to know about them. There's a lot more than we will cover today, and I think you can have like 2 courses on it at university at least, probably more if you want to go really deep, but we will cover like the basics. And then we will talk about what can we do with state machines in pinball, and that's a lot. Basically, like a pinball is a large state machine in the end. But in MPF, you're not directly seeing this all the time, but sometimes it's useful to think this way. And then we will like cover like one, I would say, common thing, which sounds scary, but it's super easy once you understand how this works. It's what to do like with state machines on mode restart, and afterwards we will like build the state machine, which I will present in the second slide. So we will later just build exactly that and implement it in MPF and play around a little bit with it. So let's get started with the first slide. So state machines are deterministic finite automatons, and there's like a Wikipedia link on the bottom if you want the mathematical details. But basically what a state machine is, or like a deterministic finite automaton, mathematically defined, it has like a finite set of states, a finite set of input signals, a transition function, a start state, I guess it's obvious, and a set of accepted states. So what does that all mean? Sounds scary, right? And I didn't copy it, but there's like a mathematical definition. So like it's a tuple of like 5 of those 5 elements, and that's what you can use to describe the state machine mathematically. But we don't necessarily want that. It's just important to understand what's there. So graphically, like the thing on the right, so this, like that's a state machine. And how that actually works is that in the beginning you got a start state that's usually called, here it's called S0, but usually it's called start. Oftentimes that you just write start here. And then you got like some transitions to other states. And for example, from S0 you can go to S1, from S1 you can go to S2, but you can never go from S0 to S2 directly. And then you got like input signals, or input symbols, how they call it. That's basically what triggers this transition. So when you're in state 0 and it gets like a 1 as an input, whatever this means here, then it will go to S1. If it's in S1 and it gets a 0, it will go to S2, and if it gets a 1, it will go back to S0. If you get a 0 in S0, you stay at S0. So that's basically what a state machine does. You can have any numbers of transitions. They just have to be like well defined. So like there can be exactly one transition with the symbol 1, not like 1 to S1 and 1 to S2. That's not possible. And it's like no longer like a deterministic finite automaton. That's important just to reason about it. So if you if you satisfy those constraints, then it's easy to reason about it. Yeah, then you got like a set of accepted states. That's basically, yeah, that's academical. That's not important for us, basically. So it just describes if this is like a valid input, if it's a valid state machine, but that's not important for us. For us, it's just to understand that like we got like a defined set of states. They will not change at runtime. So you define them in the beginning, they cannot change. You got like a finite set of input signals. That's not so important for us. It just means that like you need to know in advance which inputs can happen. And that's very well defined in a pinball machine because like you know which switches exist, which events may occur. So that's also not an issue. And a transition function basically means that you have those transitions here. And the start state, yeah, that's obviously it has to start somewhere, but I mean, yeah. And that's basically what you need like mathematically to have like a finite automaton. Then there are like non-deterministic finite automatons, which gives you some freedom, or like transitions which happen automatically and so on. But that's all not important for us. So that's basically our theoretical construct, which we will be using in the following. So that's already like the computer science, all the computer science theory I will covering today. If you got questions, feel free to ask, or feel free to read Wikipedia if you like. If you want like the mathematical details. But if not, we will go like to what does this mean in pinball, and where do I use it? And in pinball, I see like four main areas where I would use like a state machine in MPF. So the first one is like in any, or not in any, but in a lot of mode selection scenarios where the player can give some inputs, for example, where it can select a mode or qualify modes. That's often a good idea to use like state machines. You can also go like with counters and so on in MPF, but internally they basically a subset of state machines. So a counter can be implemented with a state machine, and same for all the logic elements in MPF. So sometimes there are more specialized elements in MPF, which makes sense to use them, but you can use the state machine as well if you want, yeah, more generic stuff. Because at least theoretically, you can implement any program in a state machine. So like it's Turing complete, it's how you call it in computer science. So any program which is decidable, so which terminates at some point, so comes to some conclusion, is like it is possible to implement that in a state machine. And yeah, like the next one is, in my opinion, the most important one is like mode logic. So like this typical shoot this ramp, then shoot that ramp, shoot that, then either do that or that, and then finally shoot this 3 times, and then get the multi-ball, wait for the multi-ball to end, then maybe you could add a ball as well. But then at the end, when all balls except one drained, then end the mode. So that's also something, or that's basically the main thing, and that's also what we will cover next. And we will also implement this today, so we will look into this. Then you can use it for toys. So like if you want to have some logic for your toy where basically, I don't know, grabs a ball, gets it up, moves a crane, puts it somewhere, moves something else, has some light shows, and then releases it. That's also something you can control with a state machine. That's often very, very nice. And if you think about like where this is used in your environment, that's for example in traffic lights. So those traffic lights you got on the streets, they run like some kind of specialized state machine with some field controllable programmable like controllers, right? PLCs, programmable logic controllers, yeah, that's how they call it, PLCs. And they run like a specialized state machine, and that's how you also model like safety critical applications. And I mean, your toy will not kill people, but like it's somehow critical that certain stuff happens after other stuff and so on. So it's usually a good fit for this. And then you can also use it for like some display or slide logic. If the player can control like slides to some extent, you can also control that with a state machine. So yeah, that's basically the four main things I see. Theoretically, you can do anything with it and you can use it anywhere, but that's basically what I'm seeing in typical MPF machines. So let's go on to my example, which I already teased on mode logic. And I prepared this small like state machine, which follows like the notation of the theoretical example, but is a little bit more concrete. Still not extremely concrete, but a little bit more concrete. So imagine we want to have like a typical pinball mode in any machine, I would say. So I imagine my mode has like some start state, that's the left state, that's this here, right? And then it just says, well, we lit the left ramp. I mean, it could be flashing, for example. And once the player hits the left ramp, we go to the next state, which is mode qualified. And the scoop is lit, and that actually then starts the mode when you make the scoop. Afterwards, we hit the left ramp again. That's something which is very common in a lot of machines. You qualify the mode on like the left ramp, and then the first shot in the mode will also be like the left ramp. Then if you made those shot, then you go like to shoot the right ramp. And this might, for example, happen like have to 3 times, for example. We could have a counter here, and I will also show you how we can do that. Yeah, then we go to the state right ramp lit. So we indicate the right ramp, the player hits the right ramp, it goes to orbit lit, you shoot the orbit, and then the fun starts. We start multi-ball. So we post some event, and that event starts in multi-ball in MPF. You get like 2 additional balls, so you got 3 in total. And now you're happy and very busy shooting, keeping all those balls up, making a lot more points, and so on. Then you shoot again sometimes, times out usually, and then once you drain like 2 out of your 3 balls, like the multi-ball ends, so that at least in MPF, like it will post like an event that tells you that the multi-ball ended, and we can use like that event to then go to multi-ball done. Sometimes you got like some grace period where you can still collect like a jackpot or something. And then like we transition to the start state again. But we could also like go nowhere. It could stay at this point and you could never restart the mode, for example. That might also be an option. We could also just go from here, from the multiple start to this state if we do not have any additional logic here, for example. And that's basically, I mean, it looks super simple because it's super sequential, and you might wonder, do I really need like a state machine for that? And yes, you do not need it. You can do it like differently with just cascading other like logic blocks in MPF, or I don't know, counting up a counter. There are multiple ways to do that. But this is basically a good idea to think about it. I mean, you could also have stuff like you got like a counter here, and when the counter expires, you go back a step or something, like with some hurry up shots or something. So you can have like arbitrary transitions here. Yeah, so let's like compare this shortly to the theory. So you saw like some transitions between the states we got. So first we got states, that's obvious, right? And then like we got transitions, and those are triggered by events in MPF. So your transitions are always triggered by events, and you have to define which events at configuration time. So before you start your machine, you cannot change this at runtime. But obviously you can use like event player to post any event based on anything. Then you got like events on transitions in MPF. So like when we transition from step A to step B, we can like post events, and that's useful to actually trigger like sounds, for example, or trigger logic, or trigger like a ball eject, or start in multiball. You can also have events on states. That's very similar, but like if you got like 2 incoming transitions to your state, you could have like different events on each transition, but when they reach the state will basically post like an event too. And that's also like useful if it's depending on the state. For example, if you want to start a show based on a like, or basically, for example, if you want like to move a servo to a certain position, if this state is active, then just post an event, and that event will then move your servo to that position. Because that depends on the state, and like the transition is then like if you made something, then the transition plays a sound. So that's basically where you can decouple it, and that's also like in computer science theory, those are different things, but in MPF you can decide what you want and what you need. We also got like integration for shows. So you can say, well, on this, when this state is active, just play this show. And that's, I mean, you could do this by events, but as this is a very typical thing, we decided to have like an integration of shows and states. I will show you this also in a minute, because that's very, very useful. Also from my small example, I will show you. Yeah, and that's basically the connection from theory to practice in MPF. And now like we are coming to the last point on the third point on the agenda. And that's basically mode restarts. So for example, now let me go back once. This state machine here, what happens if the state machine is in this state here and the mode stops and you start it again somehow? What happens? So there are basically 2 things, right? Could go here to the start step again, or could start here again, or it could be anything else. So how do we model that? And that's basically something we can model with the state machine as well. So we can, for example, have those transitions here. Basically, we can say when the mode starts, that's basically this condition here. Then, for example, if we are on this step, in the mode started step, go back to mode qualified. You do not have to requalify, but you have to hit the scoop again, for example. And you can, for example, here, this step, we go to qualify this also. And if the multiball already started on the last run, then we instantly just go to the start state again. So basically you're free on any state to say what will happen when the mode restarts. And that's basically very useful. You could also say stay in this state, right? So you could have like a no transition. But that's basically, I mean, that sounded scary, or I guess it's sometimes tricky for people to think about it. But if you think about it this way, then it becomes super easy and super obvious what happens. And that's that's all the magic which is there in state machines. And if you got any questions, let me know. Otherwise, we will jump into like a small demo of this state machine. Yeah. Okay. Let's do it. So what did I prepare? I prepared my IDE somewhere here. That's my IDE. And what I did is I added a very creative mode, which is called My Mode, but you cannot see it. Now you can. So I prepared this mode here, and this mode is here. And it just starts on an event and it stops on an event. And I defined like state machines here, and my mode is also the name of my state machine, because that's what I wanted to name it. And basically the first thing I say is like persist state true. That means that it should persist the state of the state machine in a player variable. And this means that if you like stop this mode and start it again, then it will continue on the state it was previously for this player. So if you in a two-player game, like every player has its own state, and it will keep track of the state. But you could also set it to false, and then it will just go back to the start state. Then I mapped like states here, and that's basically exactly the state machine I showed you. So it has like an initial state, which is called left ramp lit, and I got like a qualified state, then left ramp lit again. So you know, like start state, qualified, then left ramp lit, then right ramp lit, orbit lit, multiple started, and multiple done. And that's all the states we got. And additionally, there's basically, let me try with my IDE. I went ahead and tested like the auto completion before because I wanted it to work here. Last time it didn't on state machines, but now it works. And the language server understands everything. And so on every state you can have events when started, so when we enter the step, the state, and events when stopped, so when we exit the state, and as a label for like optical reasons, and you can have show when active, and that's basically a show which is started when this when the state becomes active, and it's stopped when this state becomes, or when we transition out of the step. And what I did here is like I got the show which is show message 1. That's a show which shows like a message on this segment display here, and I just put like the state name as a message here. So anytime we play with it, you will see on this DMD here, on this segment display here, on which state we are currently are. And let me this to the foreground, and that's already what we got. Then like this mode starts on test event 1 and stops on test event 2. That's basically the events which I mapped on my keys from 1 to 0, my keyboard, and it will also show like a message here for every event, so you will see what I was doing. And now we can map transitions, and this is basically a list of transitions, and the transitions work this way. So I can have like a new transition, and it's for example, let's say test, it's plural, test event 4. That will be my event. So on the 4 key, it will transition. And we say like source is like the qualified step, that's the second one. And my target step is like left ramp lit. And so now I got like one transition from start to qualified and one from qualified to left ramp lit. We can now like duplicate this and say like on the next key. Yeah, maybe we can also do it like on the same event so that you can see that it's working on the same event. So like the next one is from left ramp lit to right ramp lit. So you can put like any event here, for example, like your switch events, your shots, your whatever you want. That all works. And now we go from right ramp lit orbit lit, and then we go from orbit lit to multiple started. And when multiple ended, let's pretend it's on the same. For example, here we could use like 4 as next event. And now all we need to do is like go back from multi-ball done to the start step and like start. That's our first step. And let's, for example, say that's on 5. And unless I did a stupid mistake, this should already work. So let's stop my machine and start it again. Probably have to pin it to the foreground again. And I will hide my IDE. Yeah, I can show you like the machine again for a minute. So basically that's what we are now, what we mapped. So we got the states, I pre-mapped those, and I just added those transitions on like some keyboard events so that we can emulate them. And now we will play with it. Let's see what happens. Oh no, wrong one. This is the right view. Okay, so what I did here is like, and this is my MPF machine. You can also see like this is my console where it's running, but it's not so important. We got like all the events ongoing here in the monitor. We got, and that's what we will be using, like the devices in the MPF monitor. So I started the MPF monitor here. And I got like running modes, but that's just about nothing. And what I will do now is like I will add a ball to my machine and press start so that the game is starting, because otherwise we won't have player and so on. And now we got the events 1 and 2. Press 1 to see like the first event. And now you can see that my mode, creative mode, just started. And you can also see like this message. I think this show will just loop and restart every second. Maybe we can have it like not do that, but it will just restart all the time. So because the show, yeah, it has a fixed duration, so that's why it does that. But well, we can now see that our state machine is in the start step. We can also see this like in the monitor here. So it's in state start. And we can now go on and as you might remember, like 3 is our transition to the second step. So we can press like 3 and it will go to the next step. I can press 3 again and next step. Left, ramp lit, and we go right, ramp lit, orbit lit, multiple started. Now I can press it again. Nothing happens. Why? Because well, from multiple started to multiple done, I used like the event 4, so test event 4, and this transition does nothing. It's just the DMD is moving because there's also like a DMD show on the key, segment display show. And now I can press, for example, 4, and we are now going to multiple done and 5, and we go back to start, and the mode can start again. So that's already all the logic and all the magic. So let's so now we're in start, we can do it again. So we can start 3 again and go to the next step and to the next step. Now we can also try like what happens if we stop the mode. As you might remember, I set persist to true. And let's do it. Bam, the mode stopped. You can see the mode is gone here. And the show is gone. Everything's gone. The state machine, as you can see here, still is like in the left ramp lit state. And we can start the mode again. And as you can see, it's still in the state. It restarted its show. So it's showing like the show again. So that's super nice. If you like indicate your left ramp, put that show on the state, and whatever happens, if this mode restarts, it will just restart the show and will indicate your ramp again. That's like an easy way to keep state and tie it to shows. And now, for example, I can press 3 again and goes on and so on. That's basically the initial version, right? But now we can also like look at how we can go into states when the mode restarts. And as you may see here is like my mode start is like an event which is posted when my mode starts. And we will now use this event to transition from certain states. So go here again, and now we will copy this block again and say, for example, from source state qualified, we want to go back to, now we want to do nothing, right? From qualified, we want to do nothing, but from left ramp lit, we want to go to qualify when we got the event mode. Yeah, it can even auto-complete it, but it does not know the mode name for some reason. My mode started. So with this event, we want to go there. And I think it can also be a list. So we can also now say from this state, from left ramp lit, we can also then add like from a right ramp lit or also from orbit lit. And that should, let's see what happens. That should already give us what we wanted. Add a ball, start the game, start the mode, go to qualified, go to left, and now we are basically in start left ramp lit. Let's stop the mode. Mode is stopped, still in the state, because when we start it again, it goes back to qualified. Because this happens when the mode is starting technically, but I mean the player will not notice that. And yeah, we can do like then go on to left ramp lit, right ramp lit, orbit lit, and same thing, we can stop it again. And when we start the mode again, it goes back to qualified. Very simple. And now we can go a little bit further to multiple started. And as you might have noticed, I didn't add that state. So now I can stop the mode, start it again, and it should stay at that state. So yeah, that's actually what happens. It stays at multiple started. And I mean, as you probably thought about or imagine, we can also have like a transition for multiple started and multiple done. But we do not want to transition to qualified, we want to transition to start. Because if you're already in multiple, you should like re-qualify the mode. And this hopefully works as well as everything else I showed you so far. Add a ball, start the game, start a mode, transition a little bit to multiple started, and stop the mode, start the mode again, we're back to start. Because now we transition to start. And that's basically what this is. We can also do like integrate counter if you want. We can do this as an example. For example, let's say we want let's go back for a minute. So for example, let's say from left ramp lit, we want you to shoot this ramp 3 times. And now we could do like two things. So first we could just duplicate the step 3 times, and then we got like left ramp lit 1, 2, 3. That also works, right? But that has like a disadvantage that you cannot make it like configurable in service mode, because typically you would like an operator setting which says which makes this configurable. So like 3 times, 5 times, 10 times, whatever. And often ways also like if you progress and do the mode a second time, it will also, I don't know, double the number of shots you have to take. And so you want to have this like dynamic, and that's not something which is typically possible in state machines. I mean, you can do this like you have like multiple steps, and then you can shortcut based on like some conditions. So you can go have like 10 steps, and then you can check in the third step if operator setting is that and that, then transition to the end, and otherwise go to the next step. But that's, I mean, again, I told you everything is like theoretically possible in a state machine. So it's because it's Turing complete, but it's not necessarily a good idea. So for this typical scenario where you would like want a player to hit this 3 times, I would do it a little bit differently, and I will show you. So what we would do is we would change the transition from left ramp lit to right ramp lit. And we would do this the following way. That, where's this transition qualified? From left ramp to right ramp here. We would not put it on this event, but we would have like some counter. And that's what we will do here, put here in a minute. So we will add a counters, left ramp counter. And now we got like, what do we have? Count events. And we take like test event 3, that's just pretend that's like the switch event. And we got like, we got some count complete value, let's say 3. That's where you typically would like use a placeholder to reference your service mode setting. And now we also add like, what else do we got? So we got like restart events, yeah. And that's basically what we will use to start this counter. So we will use the state machine to start this counter and stop the counter. So like we will do start enabled false, so it shouldn't auto start. That's also probably, it's not the default, but I think as soon as you set like a restart event, it will be start left ramp counter and stop events. Do we need this? Reset on complete. Now we want disable on complete. Come on. Disable. Yeah, it wanted to annoy me. But yeah, that's what we want. And now when the state machine goes into the step, like into the left ramp step, the left ramp lit step, then we will start this counter. So what we will do now is like we go into the left ramp lit, and now we will do like events when started, start left ramp counter. And the transition will now be on counter maybe logic block complete, right? Yeah, logic block left ramp counter. It should autocomplete this. Something to fix for the next stream. So once this is completed, it should advance the state machine. And yeah, we will try this, and let's see how this will be going. Hope this works. Didn't try it before. So add a ball, start the game, start the mode. advance this, advance to qualified, advance to left ramp lit. Now it gets interesting. Let's look at the counter. It's at 1. Oh, here. It's enabled, it's not completed at 0, it's value 0. So let's press the event again. We are still at the state left ramp lit. This counter increased to 1, 2, 3, and we transition to right ramp lit. That transitioned the machine. So now basically we got a state machine and we got a counter. And now what happens if we restart the mode? What do you think? I'll tell you in a minute. Just think about it, what will happen. So now I will stop the mode, start the mode again, go back to qualified. That's expected. But now we go into like left ramp lit. That enables the counter again. And let's say we make the shot twice. So now the counter's at 2. And now we stop the mode. So for some reason it timed out, for example. We stop the mode. What will happen now if I restart it? Do I have to make the shot once or 3 times? What actually will happen is that this counter will be restarted because we post the event when this state, like this left ramp lit state, comes up again. And additionally, we will go back to qualified. So, but even if we would not, it would still restart this this count. So now it's back to 0. I go back to qualified. I go to sorry, I pushed the wrong button. Start mode. I go back to left ramp lit. It's at 0 again. So basically, this is voided. You can do it differently if you want, but that's. Hey Greg, how you doing? Thanks for joining in. So yeah, so that's basically a way to implement your logic. That's awesome. Yeah, nice to have you here. So yeah, so like you probably like get the idea. You can use the state machine to integrate with any other like logic block or even with like a show or sound or whatever. So that's basically your way to control like the logic. And yeah, that's already what I wanted to show on state machines. Yeah, happy to hear that, Greg. I've enjoyed making those streams actually because yeah, you got like a fixed deadline. You do not want to you do not spend like hours to make it too perfect, because then you won't do it at all. So it's nice that you guys are watching and giving feedback. So can you have a single state machine across all players? So hi Chris first. Or are they always only within the scope of an individual player? For example, if you had a cooperative mode where 2 players can help each other. No. So that basically only applies to when you use persist true. So persist true will in a mode. Persist true in a mode will use a player variable to store the state. But you do not have to put it there. So you could, for example, have a mode which is not, which is basically not stopping. So the problem you might have is actually that you would have to put it in either in a machine-wide configuration, or you would have to put it into a mode which does not stop between players. And because like normal modes track state individually, but you can also put it like in a non-game mode or in a configuration. But then you have to like a little bit make sure that you probably reset it on game start. But that's all about it. So that base mode usually is stopped between players. So that stops on ball end and is restarted on ball start of the next player. So what you can do is, for example, you can say game mode false, and that will make this a non-game mode. So this mode will then run without an active game. But I didn't do this here because I wanted to show like how you restart stuff, and would probably also complain that I set persist traits to true, because let's try. But I think MPF will refuse to start if I do that, and it will tell me that this is illegal. No, it's not. Maybe if let's see what happens if I start it. Maybe we edit it. Game mode false. It's not starting yet. I'm not sure. I didn't I didn't save the file. Let's try it. Yeah, now it crashed because this state machine cannot exist in the non-game mode, because I said like persist state true. I can set it to false, and I think if I do that, it should be able to run in a non-game mode. Yeah. But now basically it won't it won't persist the state. When I stop the mode, basically the state is gone. So that's the trade-off here. Yes, hope that answers it. So Greg, I was playing around with some counters tonight and found some dokus that said MPF can't display counter values. Is this on the roadmap to be included in MC? So yes, it's definitely on the roadmap. So currently, like what we got MC and MPF. MPF is one process in Python, and MC is like the other process. And MC has like only a limited view into MPF. So what it has all player and machine variables, and MPF can send like commands like slides and so on. But you cannot currently, for like some technical reasons, reference placeholders on slides, at least not easily. That's something we should add, and that's something which is like, that's some conceptual stuff where stuff is happening in MC which should happen in MPF, and that's like a little bit more complicated to clean up. But yeah, we got it on the roadmap. It's not that we are so much working on that at the moment. I did like a proof of concept media controller in Rust, which solves the problem like differently. But we could also like fix it on the current MC. It's not too hard. We would then basically render the text in MPF and just send over the text. So at the moment, yeah, right. So the workaround, you already found it, is to put your like placeholder into a player or machine variable and display that. Or what's also possible is like you can use a show, because what happens is like that show tokens are evaluated on the MPF side, and that includes anything. And then inside a show you can have like a widget, and then MPF just replaces the token and then sends over the widget. So MC never knows that this has been like a placeholder, but it just gets the value of the placeholder. And that's basically conceptually better. And that's also like a workaround which I sometimes do here. So for example, on my segment displays, I do this here. I got a show, give it some show tokens, and then this is just replaced in the show, and that's very efficient to work around the problem. So yeah, that's also what I do like for those shows. I mean, that's basically just for you to see this here on the display, but you would usually have a different show on each step here and use it to indicate whatever you want. And you can also like reference the state of your state machine in conditional logic. So as you probably imagined, as it's in a monitor, this would be like state machines, my mode dot state, and there you got like start or whatever the current state is. So yeah, and you can like use this to base any logic on your state machine, for example. So anything else you want to know? Looks like a state machine can do the same as a sequence logic block. What would be a scenario where you would use a sequence logic block instead of a state machine? Basically, like a sequence logic block is a strict subset of a state machine. So my state machine is basically a sequence logic block, right? So except like for the restart logic, that's something which would be tricky in a sequence logic block. It's just simpler. I mean, the sequence logic block is just for very simple stuff, but I would say for any real mode, you want to use a state machine because it's much more flexible and, in my opinion, also easier to debug at runtime because you got a clear state, you know where you are. And in a sequence logic block, it's like it's step 7. And then you count, it's 1, 2, 3, 4, 5, 6, 7. Okay, I'm in this unnamed step. And this is just a little bit nicer in my opinion. But conceptually, you just have to like wrap your head around it a little bit. So once you understand how they work, in my opinion, you usually want to use a state machine. So yeah, hi, and welcome. And yeah, that's probably a good a good point of time to watch the stream then. So what's your game you're building? I know for the other people, so that's why I'm asking you. So yeah, I mean, it's never too late to restructure stuff, and I mean, it's rare that you get stuff right on the first run. You usually change stuff later on, and so it's yeah. I often write stuff and later say, well, let's just make a state machine out of it because it makes stuff easier. A Wu-Tang Clan on a rethemed Demo Man. That's nice. Yeah, Greg, thanks for joining. Have a great afternoon for the Eurovision final. It's still ongoing. Nice. Have fun. Yeah, see you later. So, yeah, anything else you want to know? Otherwise, I didn't prepare anything else for today. And I guess my more machine isn't so interesting for you to watch for a longer period of time. What are some possible issues people should be aware of when using state machines? Any expert tips? In my opinion, draw it on paper. It's helpful to have like, or like in Visio or like any, any like architecture program like Enterprise Architect if you're in IT, but any like even PowerPoint will do. Just note it down because it's useful later to understand what you tried to do back then. Because usually, I mean, you write it, your mode is fine, and then half a year later you find some logic bug and you need to debug it, and it's useful to like have a visual representation of it. I mean, theoretically, we could render it out of the MPF configuration, but we do not currently have that. If somebody wants to build that, we would be very happy to include it in the MPF monitor. But yeah, that's Also, I mean, it's also useful like for like a manual of your machine, for like operators to understand what's happening, and or maybe also for players. I mean, sometimes if you see like descriptions of the mode tree and how this happens, that's also very similar to the state machine representation I showed you. So it's basically dual use. It's documentation and planning for implementation. Do that. And otherwise, just think about like what happens on restart. That's why I had this restart section. But once you understand how this is working, it should be easy even if you forget it. So to add it later. Also what you might notice is that you can post events on the state and on the transition. So if you like restart a mode, you will only get the event on the state. So if there's something which is related to the state, put it in the state. If it's something related to the transition, put it in the transition. But because on restore or reload of the mode, the transition usually won't happen. I mean, it might be another transition. You can also have like a transition from the current state to the current state on mode start. And this way you can have like another event on mode restart basically. That's like the like a small trick to restore stuff on mode restart. Because sometimes, for example, like you got a lock and the player needs to make, I don't know, needs to make this lock and some precondition needs to be there. So like, for example, a certain diverter needs to be left, and then you would post an event to restore the diverter to the left state. Otherwise the player can't make the lock, for example. Kind of, that's sometimes something like that. Or in my machine, for example, I got a lock and there's a mode which is on this lock, but you can also stop the mode, put a ball in the lock, and then start the mode. Then it's basically in the state where it's waiting for the lock to be filled, but the lock has been filled while you were not in the mode. So on mode restart, I check with the conditional logic if the lock is already full, and if it's full, I skip this step, because otherwise, I mean, the player would be stuck in this state. But that's a typical, that's the races between like logic and physical stuff, and which you usually will find once you play the machine. So yeah, that's my take on it. Okay, so unless you got anything else, I mean, feel free. I didn't prepare anything else. Okay, then thanks everybody for joining. Hope you will have a great weekend. So enjoy your weekend and build some pinball, hack some MPF, have fun, stay curious, stay learning, and hopefully see you like on Wednesday. We will probably do something about magnets, I guess, because somebody wanted to see magnets, and it's a great topic. We will look into like some mechanical stuff, how it's working mechanically, electronically, and how it's controlled in MBF. Also like some special stuff like the Stern magnet control board, and that would be great. So maybe see you on Wednesday or see you around in one of the many chats. Have a great time. Until then.